Hello, everybody. Thanks for joining us. Dr. Farusa from Africa University is going to be joining us and giving a guest lecture today. Now, I have sent out an email that has kind of like a pre-test, if you will, or just a little bit of just a few questions, like 5 questions, just about your knowledge going into the lecture, because we're trying to see how that changes afterwards. So I've also posted it into the chat, so feel free to click on that and just take a couple seconds out to answer those questions. It's not very long, they're multiple choice. And if you don't know the answer, just guess. That's fine. Everybody see that link that's in there? I'm gonna paste it. I know if you just come in, it doesn't show up, so I pasted it again.
We saw it.
Okay, great.
I am done.
And with that, let me go ahead and we go, and I'm going to go ahead. We're recording now, so go ahead, Dr. Farusa, take it away.
Oh, okay. Have you already given me the question first?
Yes.
Thank you so much. I'll share my good morning, everyone. It's already mid-morning day. It's still very early. So let me know if you see the PowerPoint. Is it clear? Can you
Yeah,
see?
it looks
Yes,
good.
All right. Thank you so much for the privilege I have today. We're going to be talking about climate classification. And I want to, first of all, appreciate all of you. I've been joining here and there to see you participate. I think you are a very active group. I'm proud of you. So today, on climate classifications, unfortunately, I'm not a very physics person. I'm a social scientist, so I'm speaking from a social scientist perspective. This is what we know about the world climates, and also who has been in all that. The Greeks, just like, in any other philosophical issues, they've always been credited with some of the early works of science, even though there are others that have participated. But the Greeks the studies show that they were the first to analyze and classify climate zones according to temperature. And they came up with these 3 zones, which they gave their own names, but now, like the torrid is what we call the tropical, and they had the temperate zone and the frigid zone, which is the polar zone, the polar region. So what they were determining, what they were trying to share with the world was that there is a certain place where there is homogeneity or uniformity in the way the temperature is experienced. So this was our first test of classification. However, we have this guy called Vladimir Koppen, a guy belonging to many countries, born in Russia, he grows up in Germany, he ends up the last days of his life in Austria, so he normally just called a German Russian. Vladimir Koppen also studies the climates. He's almost credited also to be as close as to a few others as the father of climatology. So he now looks at much more parameters than just what the Greeks did. He looks at temperature, he looks at precipitation, and then as a botanist, he also goes on to link temperatures and precipitation to vegetation. So this is the work that we are looking at today. We are going to focus only on Vladimir Koppen. But because these studies were done way back in the late 1800s into 1900s, what people have done is to rework what he gave the world, what he produced as a scientist, especially when he worked with Alfred Wegener. We know him for plate tectonics. So they worked together and came up with so many of these ideas, but people have reworked these ideas. They've changed and modified his thoughts, but I'm going back to his original findings. So Köppen talks about 5 types of climates. And I wanted to use this slide so you can see in general the percentages for each climate zone. So we have the tropical climate, which covers 22.2%. And then the dry climate, being the one that is more expansive than others, 32.2%. And then we have the temperate zones, and then the continental zones, and lastly, the polar regions. So what is it that is said about these zones? When we look at Köppen's presentation, it shows that a lot of little words, these abbreviated or shorthand, that he used according to how, the scholars write about it. It's so confusing. It's too many colors. It's just too many words. What do they mean? So this is what we are about to do today, to break down what that means, because this is the basis for any form of classification we have, so that we can say, oh, that is a tropical climate, or for geographers, sometimes you just love to know where you are going. You want to understand how the climate is in terms of temperature and precipitation, but we know it's much more than that. So we are also going to look at those other elements which defy what Köppen said, and then we incorporate them. And I know, like in the backdrop, we are working with climate change. So I want you to keep on thinking, like, how is this changing because of climate change? How is this altering what Köppen said because of climate change? And I would need you to be able to come up with some decisions. One thing that I've seen Dr. Panaki, with you guys, to work as we go, do some activity, go. So I expect that in this class, we're going to do a little bit of work, but let's start off with just the meanings. As I said, the writers, the geographers that came after Köppen, they were modifying what he did, but generally his classifications are from A to E, which means there are 5. But even in them being 5 like that, there's a difference in the way we talk about the climate types. For example, we pull the B out. We pull the H is the addition. This is the modification, which means highlands. So his were A, B, C, D, E. But there's something common about A, C, D, and E, which does not integrate B. So the A would be our humid tropics. And I know that you guys, okay, maybe I'm not sure whether you have a geography background, but I'm going to share with you a map which shows, the tropics or the subtropics, the polar regions, just the general idea. So the A, C, D, and E, according to Köppen, were his classifications according to temperature and precipitation. And then as a botanist or somebody who was interested in vegetation and studied vegetation and is also linking that with the rainfall and temperature, he would also see how that is influencing the vegetation. So there's some sort of uniformity in vegetation of those zones. So it's purely temperature and precipitation for A, C, D, and E. However, when it comes to B, which is the standout, the only kind that's different from Köppen's presentation, this one is about precipitation only, and then elevation. As we said, there are some things that might have changed even after Köppen's presentation. So B is singled out of the A to F because it does not really into the concept of temperature. And then the highlands were added on because we know the effect of highlands. And I brought in on my PowerPoint a few examples which are going to look like what is the difference in let's start even with the weather, one side of the mountain to the other side of the mountain. at the foot of the mountain and at the top of a mountain, especially, for example, high mountains, let's say the Kilimanjaro or the Andes, those humongous, long stretching mountains, the Atlas Mountains and stuff like that. What is the difference? So the highlands slightly different. They don't just go by the latitudes or by the zones that have been already set. So that's why the later geographers started to throw in that as a different component. So more detail now, let's go closer and closer to the classifications. So just for general geography, it is important to know our latitudes because this is what gives us the tropics. And the key is very clear, the equatorial zone, which is in a dark red, we can see that. And then the sub-equatorial region or zone is more of the brighter orange. But some of the times, geographers combine these to just make it the tropics, as long as they fall between the Tropic of Cancer, which is 23.5 degrees north of the equator, and the Tropic of Capricorn, 23.5 degrees south of the equator. So we have geographers that bunch these places together to just call it the tropical region. But we know that if we zone in, we can see that there is another sort of dimension, especially looking at the temperature and rainfall and the vegetation, which we can single out and say, this is the equatorial region. This is maybe 5 to 10 degrees north and south of the equator. So we single it out from the rest of the tropical region. Then we have the temperate regions. And as you can see, the dark green there, the temperate regions, also bring between them and the tropics another zone, which is called the subtropical zone. And then we have the polar regions, which are dark blue. Of course, it's not showing much of the southern part. We can see, of course, the northern part, but our Antarctica is hidden. Perhaps the person who did the map was trying to accommodate the key, which is very critical. So between now the temperate zone and the polar zones, we have the subpolar zones. So this is just a reminder, just in case, you might have done this a long time ago. Usually this comes in your early university studies, like your courses. So I want us to now zone in. So for those categories that Köppen came up with, the 5 plus the additional highland region, there are temperatures that are noted. For example, sorry about that. I think my slide shows that there's been a cut in a few weeks at the end, but don't worry. What we see is that with the tropical regions, it's usually the minimum of the temperatures will be 18 degrees. And then everything else above, sometimes all the way to 27 and 30. This one is based on degrees Celsius. I know we come from different backgrounds. We might actually deal with degrees Fahrenheit. And we also want, you guys are very good with your science. You can actually see the difference between the degrees Celsius and the Fahrenheit. You can get it, the formula, and turn it around if you are more comfortable working with degrees Fahrenheit. So we can see that B refers to dry climates, and you're already thinking a desert, but also think of the fact that the deserts are different. We have cold deserts, we have hot deserts. Each of them is formed in a different way. And for somebody who came up studying geography, perhaps in the 1980s, this geography is changing so much. We came from just saying we have 5 continents. Now we have 7 continents, and another 8th continent has just popped up. Zealandia, we lost, we lost Pluto as a planet. Things are changing. Why I'm saying this is that we have certain words that will appear in the newer books, which are not appearing in the old books because of the change in the language. Or in the geoliteracy that we have now, we are changing the language. So the dry climates, there are some that are cold and wet, and also dry climates that are really dry, hot, like the Sahara Desert. And yet, if you talk about the Antarctica, it's dry, yes. There's also a lot of water around, the like those glaciers in the ocean. So this is what you would see now in current studies. So we also have other regions such as the warm temperate zone, where the temperature can go to -3 and also even go as far as below 18 degrees Celsius, and so on and so forth. This is just the general characterization of Köppen's classifications. Now, the little letters and the abridged as well as shortened or shorthand words that you saw on the first map, they mean something. So there are 3 categories that we have. The first letter is showing us the name of the region. So it would be A, so that if we have a classification that is A at the beginning, you already know that we are talking about the humid tropics. If it is a B, we already know that we are talking about arid areas. But what is it in that arid area which will differentiate it from another place? Is it a desert, which means a capital W or uppercase W, or is it an uppercase S, which means a steppe kind of climate? We have to be very sure when we look at these words, and be sure to use a capital where there is a capital, or uppercase where there is uppercase, and lowercase where there is a lowercase. We have a lowercase s, which means dry summer. But if we go to the arid climate, you find that the uppercase S means the steppe climate. So the second group of letters on each example you are given will be referencing temperatures, moisture. It represents moisture. And then the third represents temperatures. So what is that area that is humid tropical experiencing? If it has a little F, it means that it's wet all year. It's fully humid. And if there's a W, it talks about, the savanna, which would be like cold, dry winters and hot, wet summers. So you already have an idea by just seeing that W. And then if there's a little M, then it means it's a monsoon type of moisture. We know the monsoon winds in Asia and how they cause, heavy rains, sometimes on the land, sometimes, in the ocean. We need to look at that pattern. That's another thing that I was going to just have you, with the permission of Dr. Panasik, to do those little videos. Dr. Panasik, we may talk outside of class. I want them to do a little of the videos on those intervening circumstances. So this is what it is. And sometimes you look at it and then you think of the periodic table that you did, when you were in your early days of high school. Sometimes you memorize it just to say, I need to know what this K means. Is K potassium really? But sometimes you just have to get it in, and then practice. So this is the slide that I know you are going to have to work with in order for you to master the classifications. And so you do not really need in this day and time to memorize like we did during our time, because the slides will be available and this recording will be available. So we can always go back and say, oh, okay, this one is actually a CFB. What is a CFB? If it's C, then it means we're talking of a humid, subtropical climate. And a B, what's B in there? B means it is warm summers. What about F? F, it means it is wet all year round. It's humid all year round. So now we have managed to break the code, because we're supposed to be able to say, when we go back to that map and see those codes, they should make sense. So the way Köppen put it together it was to give a brief description of the climate of a place which naturally is assumed to be uniform. And as I said earlier, it definitely will not be uniform throughout the year and over the years, because eventually some changes come in which might cause some of the characteristics not to be so uniform, but generally there's homogeneity, and it can be a summary. But let's not forget that even in that huge zone, there might be mountains, there might be lakes that might cause some microclimates there. But generally, we know that, oh, this place, it's wet all year round. It's actually humid. It has warm summers and dry winters because of what we are looking at, those abbreviations. So this would be your friend, this slide here. So then in all, I found a slide which we can actually look at the different abbreviations together with the characteristics and the groupings that were done by Copen with the additional highland at the bottom. So here we are. When you are just told, we did the CFB, when you are just told that, oh, this is a region that is dry, so where there's no dry season, it's warm and cool. It doesn't quite make sense unless you go back to really understand, like, so what is the F about? What is the B about? Why do we have a lowercase f there? And yet on the E climates, there's an uppercase F. What is the difference? So this is what now you do in your practice time to find out what the BWK with an uppercase W would mean. And then at the same time, you do not want to forget that map which gives you the location. Because right now, I believe that all of us are in different zones, and we are in particular continents. So where are you in that continent? Where are you in terms of the latitude? What is it that you experience in the summer? And what is it that you experience in the winter? Then we zone in now to actually carry out, an understanding of the actual characteristics of that area. So I want us to do a little bit of practice. I had put this, I need you to copy this, maybe somebody can type it in for me. I had picked BWK and DWD and DFB. So if you can just copy it first, and then we can take this narrative back to that slide with the meanings of those abbreviations and see what we come up with. So we already did we did CFB, so DFB is fine. All right, so let me see if I can, I didn't want to escape. Can somebody copy and paste in the chat? Because if I escape, then it minimizes my PowerPoint. Is there anyone who has copied that to put in the chat?
I put in the first three.
Thank you. So let's go back. Let's practice together. Let's see. I think Dr. Panasic, you normally want them to just put the responses in the chat. Can you be my helper so you can check the responses and we can see if we got it?
Absolutely.
Right.
So what would BW capital WK mean?
Yes.
Folks want to enter that into the chat. You could send it just to me or to the group. Okay. Yep, that's correct, Brenda. Arid, desert, and cold.
Yes, that's good.
So everybody see how that's working? So there's also D lowercase w, lowercase d.
Mhm. Yep.
Yeah, Caldron, that's right. Seems like folks are getting it.
All right. I'm excited. I know this is a smart class.
Yeah, we got the next one, humid microthermal, dry winter and warm summer. Good. And then the last one was DFB, F lowercase, B lowercase. Yeah, that's looking good.
All right.
Yep, I think everybody's got it.
Okay. And I'm proud of you guys. Thank you so much for the practice. And that's how we go. So when you get to be writing your papers, now you can put in those summaries and it will make you go faster, you know, with whatever you'll be doing in terms of your research. So there are so many of them, but then I wanted us to kind of look at this highland concept. Why did other people choose to bring in the highland concept? So let me see if we can, that is the part where you're supposed to put in your materials. We will also come back to those, you know, the different scenarios. But I also wanted you to know that even when Copen put together that material, the representation of that material was also captured in form of graphs, so that when you are given a graph, you should be able to determine also in which climatic zone it belongs, because you are given the temperature, which is usually a line graph. And then we have the bar graphs at the bottom. And these can take any form of shape. They can be cylindrical, they can be you know, rectangular, but the rainfall is shown always at the part at the bottom, the precipitation, sorry. And then we actually see the total rainfall in terms of millimeters on the left-hand side. So we know the X and Y axis from math. And then we also have, you know, the temperatures showing on the right-hand side. So it goes as far as the lowest that you can go for the region that the place is found. So let me see if there's anyone who knows how to interpret this diagram. How do you describe it when you are given a diagram like this? Let's start with this one to the left. I didn't want to put the name before you were able to practice, you know, describing it, just in case Desire might say, oh, I come from this area, I know it, and then you describe it from your background. Describe it from the graph as you see it. It's deductive reasoning. Let's see what you can come up with.
So go ahead and put your comments in chat or speak them out loud.
Yes.
Who wants to take a stab at this? Desire, you want to take a stab at this?
I'm still digesting.
This is just describing it. I may not have been very clear. This is just describing that graph in terms of what you see, its temperature and precipitation. This is not necessarily putting it into the categories we've just gone past. I'm just showing you that climate will also be represented by graphs. So just describe what you see using the months that I provided and the temperature as well as the precipitation figures given. Like we would call this one, let's call it place A for now, and this is place B.
Okay, I'll try. So for place A, let's look at the months from January to December. So in terms of precipitation, we have rainfall or an increased amount of precipitation around mid-year, which is around May to August, though there is a steady increase in precipitation. But from January, February, and as well as the end of the year, it's pretty dry relative to the to mid-year. And we have also the highest amount of precipitation in June, which is mid-year actually. And for the temperature, it correlates with precipitation in the sense that it rises steadily and it has its highest around mid-year. But for this one, the highest temperature is around July. Then it steadily goes down. So it like steadily goes down, tallying with the month to December. So December, January is around the same.
Yes, I would say that's a good answer. Good observation. And why do you think that we have the highest rainfall totals, like you said, correlating with the highest temperatures, highest rainfall totals, high temperatures? What does that tell you? Anyone? Even you, Desire, because you said it. You said your answer was really correct description. What
Hello.
means?
Hello.
Yes.
Yes, I think that the temperature, the higher the temperature, it also affects the weather. The precipitation, the higher the temperature, the higher the precipitation.
Yes, and I want to know the reason why. Your answer is very correct. Why is it that we have very high temperatures and now we have high rainfall in that part of the year? What is the correlation? But the answer is correct. What you said is correct, and thank you. So anyone to add a little bit more insight on that?
It's that we are in the humid region.
Say again.
It indicates a humid region.
Oh, okay. Thank you for that idea. And we can come back to that. So the whole concept of air rising, I think Dr. Panessa might have touched on that. I'm not sure if you have, because I've missed some of your classes, but you have to understand that, areas of high temperature, which means there would be a lot of evaporation taking place, a lot of evaporation and transpiration taking place. And therefore, as the temperatures go high, it means that there's a lot of also the transpiration happening. And most of the time, this also leads to condensation and then clouds forming and then heavy rain falling. And so the fact that it is hot, there's that condition that has been created for moisture to be able to rise either from the ground, from the open water sources, from the plants, to be able to create those clouds for the precipitation to come. So when, like you observed, Desire, when there are lower temperatures, then we have less of that, even there's less activity in the atmosphere, and therefore it also brings lower precipitation. So that's what we see on that graph. And who wants to guess where that is? make a quick guess? Because I didn't put the name for a reason. Or maybe think about it. Let's have somebody just go to the second graph while you are thinking about the name. Let's have
Hello, Prof. Hello, Prof.
Hi, Shepard.
Yes, I think it's in the tropical.
It's in the tropical region. All right, so
Yes.
we'll find out. There is a name, I just hid it. It's there, and I'll show you. Thank you so much, Shepard, for your thoughts. Let's have somebody describe this other graph. It is so different. Because when you study the different or the books, you can either be given the graph or you can be given those summarized descriptions of climate classification. So what would you say about the second one? What's happening to the rainfall graph? What's happening to the temperature graph? You want to say something, Glory?
Yes, Prof. I think the temperature here is at the increase at the beginning and gradually decreasing before it increases again. And this shows that there is no precipitation taking place and the temperature is actually high, there's no precipitation. And there's less of water, there's no water, that means there's no precipitation taking place. So the temperature gradually decreases and then increases at the end of the year.
Yes. So when you describe like that, that's good. I also want you to pick the figures, pick the temperature level so that you can qualify your response. The lowest are in August. Give us a figure for August in your just when, for the sake of when you're doing your
okay.
That's very true. We don't see any blue rectangles like we did the case A. So it means that there is no rainfall recorded. It might be for that particular year. It might be for the region. It might be where rain doesn't fall at all. Here in California, we have what is called the death desert. There's no rain that falls there, but there will be places like that. But this one, would you say it's in a cold region or a warm region? Going back to Ruben's ideas, warm or is this cold?
To be a warm region.
Look at the temperature. Look at the graph on the right. This is the temperature. What is the temperature reading? The estimate for August, so that we can be able to tell you the parameters given.
August is less than 40, let's say around 30.
No, here is August. So you
Yes.
go from there, draw your line to the axis.
Around.
And then this is minus 60, the one that is right above it. Sorry, my mouth just frozen. This is minus 60, and your August is there. So what would be the reading? This is minus 60, this is minus 80. Somewhere in between.
That should be minus 30.
That would be minus 70.
Imagine, minus 70, is that cold or is that a warm region? Now I want Glory to answer that. I think don't lie.
It's
Minus
the
80,
warm.
minus 80 means what to you, Glory?
It means the warm temperature.
It means a warm temperature. All right, let's hear somebody else. What do you think? Thank you for trying.
It's actually cold because negative, anything below 10 degrees Celsius is cold. So from 0, I think 0 is like the freezing point of water. So anything below that becomes really cold.
Cold, yes. We already, just by looking at this graph, we already can tell that, oh, this must be, what Copen talked about, the polar. Let me go back and show you a little bit of the other things that we saw. That there would be other areas that are polar regions that are in the polar areas, which is very, very, very cold. And we can also tell on his, scale that he has regions that are called the tundra in the frost areas. And so the temperatures are already below 0. So we expect this place to fall into the category E. Because if I was giving you an exam question related to this, I would say, to which category does that graph actually fall? Then I would expect you to say in the E category, because it really shows very clearly that the temperatures are very low. So this is important that you notice that the representation of climate classifications can be done on graphs. And these graphs give us the mean temperatures or the average temperatures and the average rainfall. But does it mean that we're going to have the exact same numbers of degrees experienced or even the rainfall experienced? Not exactly, but there will be a uniformity, there will be a standard number that represents the average temperatures and rainfall. So please take note of that. Hold on, I moved my labels there. So then I want you to focus on why do we classify these climates? What is the importance? And I want you to also make use of the pictures that I've given. I have like 7 points that I put together. I just wanted to see and come up with maybe just 3 for now, and then some of it will be part of your homework. So why do we study? And then
Answer?
why what is it that's important? Because I'm going to show you the other interventions or the other situations which will change what Copen talked about. But before, I need you to tell me why it is important for us doing this. Why classify? Are you putting responses in the chat or you are talking? I also want you to talk. Makes us.
Yeah, say out loud, please.
Okay, so I think it's important to classify climate. From the picture that is shown, there is the first picture where we have certain areas with climates where it's good for settlement. Some are not like habitable. So these are places where we would know that this is not a place for settlement. There are some climates that are okay for farming. Others are okay for what do you call this? Farming in terms of food production and farming in terms of livestock.
Yes.
So these, sorry?
No, you're right. I'm saying yes. I'm agreeing with you.
Oh, so yeah, basically these will be the reasons. So we classify to just get a general idea of places and what they are good for so that we get the best out of those places.
Yes, and I thank you so much, Desire. And Shepherd is saying so you can know when to vacation. That is very, and the growing crops and breeding of animals. Shepherd is also agreeing, and Shepherd really know much in that area. That's your territory. How about this picture? How about this picture here in the far bottom left-hand corner? Anyone?
It would be to kind of gauge or get a certain understanding of the likelihood of a disaster in a particular area. With knowing the with knowing the type of climate that's kind of synonymous with that area. I'm assuming that picture is of maybe California or maybe Hawaii.
Yes.
Okay, yeah. So, having an understanding of the climate in a particular region would better assist in kind of predicting or forecasting natural disaster. In this case, this was an earthquake. It seemed like.
Yes.
Earthquake. Okay.
Yes. So that's right. And you know what? I just threw it in there in between so that we could see now why knowing the uniformity of the climate of that zone is not enough, because you would be thinking of growing crops and you will be thinking of rearing animals. You will be thinking about how safe am I in this area. And therefore it leads us to explore other things that might change that situation. So I gave these as responses, and because this is being recorded, you will get to read about these. The summaries would help us with more than what we just talked about. But I'm looking at the time and saying, I want you to also know that there is a situation which you need to look into. What controls climate? And these are this refers to these responses here. I don't know why it's not showing clearly. Can you see? Because for mine, it grayed out.
It is grayed out.
Grayed out. But can you be able to read that we have being a place being in a certain latitude already means that it's different in terms of its what it receives in terms of our global wind systems, as well as the water currents, and then also the elevation or the altitude, which we talked about, as well as the different water bodies. Like right now, if you are thinking of Africa, on the western side of all continents, we have cold waters. And those cold waters, instead of them causing rain to fall on the continent, there's an upwelling of cold, salty water from the ocean. And so when a wind, which is coming in from the ocean going on towards the land, passes over them, it causes those water bodies to release that cold water, which creates fog instead of rain. So we have our deserts on the western side of continents. So things like that are interfering. And therefore, when somebody is choosing where to live or where to go or where to work, these become the things that will shape your choice of place, in addition to what Copen said. So I can just show you, maybe if you give me a few minutes, Dr. Panasik, to just wind up. For example, picture, it is showing us that in a mountainous region, what we experience at the foot of the hill is different, from what is at the top of the hill, because we can see that that's an ice cap. So here we have luxurious vegetation that's enjoying the warm, climate at the base, and therefore with the deciduous trees that we have there is because of the temperature and the precipitation that we have. And then as you go up the hill, it becomes closer and colder and colder. And now you see the emergence of pine trees and even grasses that do not need much moisture as compared to the huge trees that you find at the base. So telling us that, inside a continent, even if it's in a region that is supposed to be a warm or a humid region, there will be other places that will be different. Think of this one. This one is very popular. We all know about it. One side of the mountain, which we call the windward side, just because there is a water body from bringing moisture, which is warm, and a wind which is warm and moist, will give rain, more rain on the windward side of the mountain. And when these winds continue to blow on the rain shadow area or the leeward side, they have lost moisture. They have already lost what is needed to bring rain. So the winds will keep blowing, but they've lost the characteristics which will make that place have vegetation cover. So we have scanty vegetation cover. So it's one region. Yes, it's the tropics, but what is there in the tropical area? Are there any mountains? What effect do they have on the local climate? So there are so many of these conditions that we can talk about. The waters. Where are the currents that are passing by your continent coming from? Are they coming from the tropics? All those red line means that these waters are heated up because the tropics are warm. And when they go north, they are bringing warmth to those particular areas. But those that are in the Antarctic or the polar areas, Arctic and Antarctic, they are in the cold regions. They will also bring cold water to the other parts of the world, like the Benguela current I was talking about, the Peruvian current, Californian current. Every day here, in certain seasons, we have fog. Because of that upwelling, that cold water doesn't bring rain. It makes this part dry, in as much as causing a place to be called a desert. And so we also have other currents in other continents having the same effect. So even though Köppen gave us an idea, but this idea actually needs to be modified a little bit in terms of the little microclimates we have in the world as a result of those factors which I talked about. So lastly, another slide that grayed out, but I was saying, so what? So what about this classification and climate change? I have pictures here, I maybe just dwell on that. The bees that come to a flower and collect nectar and the whole process in the ecosystem. So when climate is changing, those zones that we already know to have particular, climate characteristics, we expect the flowers to flower at a certain time so the little insects can come in. So now the changes that you have already mentioned, I think in one of your classes with Dr. Panasik, I heard you talk about that, where now there are going to be changes in the climate and changes in the, delays, as well as maybe quickening of processes of plants ripening or flowering. The same applies to the animals. So there's going to be a mismatch. There's going to be a mismatch. So what does it mean to our classification? So now our plants are not going to grow according to the characteristics that were surveyed and also put together by Koppen and others. So there will be a little bit of changing on all that. And if we get time, another time, we could actually also explore more of that. But Dr. Panasik, I just wanted to see if you can help me to share a little bit of work that they can do. I think those videos work very well, and I don't know if I can access them, but I would really want them to show.
Yeah. So send me the prompt that you'd like to have for their peer teaching, and I'll go ahead and post it later on today.
Yes.
And then get them started on explaining kind of what you've talked about. If you could just go back just a few slides. I just wanted to point something out. It's the one with the different, yeah, keep going back. One more, two more, I think. Keep going back. One more, right here. Yep, go forward.
Go ahead.
Next one.
Oh, the next one.
Yeah.
All right.
Yep, yep. It was the one with the different levels, the different zones of temperature. No, it's forward, I think. No, forward, not back. Yeah. Right there.
Okay.
So, question to the class based on what we've covered so far. Why is it warmer by the ground and colder as you go higher up?
Yes. Can we make that one of the questions they will have to answer?
I want you to think about it. We'll talk about it more on Monday. But
Yeah.
from what we've already covered, does anybody know the answer off the top of their head? Based on how you build climate models?
Mhm.
Why would it be warmer at the bottom than it is at the top? I mean, you got sunlight still coming in, at our solar constant. Why is it warmer at the bottom than it is at the top?
Is because the culmination of energy coming from the Earth's surface after reaching the Earth's surface from the multiple atmospheres utilizing the sun.
Right. You can think
The
of
higher
each.
you are.
Yeah.
Yeah.
Go ahead.
Oh,
Go
I
ahead.
was gonna say, the higher you are from the actual surface, the kind of cooler it will be because you aren't directly on the surface. You won't be getting the bulk of the energy being released from the surface after all the energy has been summed up
Right.
for it. Yeah.
Right. A good way to look at it is the number of layers, right? If you're higher up, there's fewer layers above you. And remember, it's the absorption of the atmosphere, the greenhouse gases, and then they re-radiate down, which helps heat the surface. So the closer you are to the ground, the more radiation coming from the layers. Go higher up, there's fewer layers above you, so it's cooler. Just thought I'd relate that. Thank you very much, Dr. Farusa. Anybody have any questions? Otherwise,
Yes. Thank you so much, Dr. Panasik.
okay. I'll cut it here, but go ahead and send me the prompt, and I'll go ahead and put that in our in our Flipgrid and send you the links for that.
All right. All right. I'll send you right away. I'll just draft it right now and send it to you in a few minutes.
Okay, sounds great. Thanks, everybody. Have a great day. And thank you, Dr. Farusa. This was great.
I appreciate the opportunity, and thank you guys for meeting you. We'll meet soon
Okay.
again.
Thanks.
To Dr. Panasi. Bye.